Welcome back to the Deep Dive, where we take the world's most complex shifts, filter out the noise, and break them down into practical, memorable insights just for you. Today, we are strapping in for what feels like, well, maybe the most urgent deep dive we've ever conducted.
It certainly feels that way.
We're focusing squarely on the ground that seems to be collapsing beneath the feet of every technologist out there. We're talking about the so-called AI Great Escape, or maybe more brutally, the layoff storm.
It really is the unavoidable defining professional topic of 2025. It's on everyone's mind. Our sources for this, and they're extensive, we're talking analysis, white papers from major tech strategy firms, aggregated industry reports, they all paint a picture of just extraordinary turbulence.
And so our mission today is what? Exactly.
It's really dual. First, to synthesize the deep-seated drivers of this, this current job crisis for programmers. And second, and I think this is the most important part, is to chart a clear, actionable survival map, detailing exactly how adaptation and strategic skill building can separate the obsolete from the newly essential.
And we have to start with the sheer scale of the disruption, because I think that puts the fear we're all feeling into some sharp quantitative relief. This isn't a cyclical recession. It feels like something else. An employment crisis fueled by a technological engine upgrade AI that's colliding violently with a very volatile global economic environment.
And the numbers themselves are the initial shock we need to anchor this discussion. The data we pulled for 2025 is genuinely stark. It reflects a fundamental structural change, not just a temporary market correction.
So what are we looking at?
The sources show that over 400 companies globally, and this list, it includes the most respected names in the sector.
It's giants.
The giants, exactly. Microsoft, Google, Meta, they've all executed large-scale layoffs. This has resulted in more than 180,000 jobs cut.
In a single year.
In a single year.
Yeah.
And that number, 180,000, it feels abstract until you
annualize it, right?
Yeah, when you break that number down into the daily reality, you're averaging 500 people losing their jobs every single day.
Yeah.
That level of systemic sustained force is what necessitates this conversation. This isn't just a blip. It's a fundamental rearrangement of how human labor interacts with digital production.
And what's absolutely crucial for you, the listener, to understand is that this crisis isn't monolithic. If you only focus on AI, you're missing half the story.
A huge part of the story.
Our analysis highlights three major converging forces that are fueling this crisis at the same time: macroeconomic pressure, corporate strategic adjustment, and of course, AI substitution.
Okay, let's unpack this and pull apart those three components, starting with the biggest force that kind of set the stage.
Right. So if we think of AI as the active sudden lightning strike, then the global macroeconomic climate is the immense invisible storm front it's born from.
Okay.
We need to detail this global pressure because it forms the background of the crisis. And it's vital to stress this point, especially for anyone who has recently faced job loss. Not every single layoff you hear about is purely AI-driven.
That's a really important distinction. It is. Many are driven by desperation and a fight for basic corporate solvency.
I think that's critical because it prevents this blanket assessment that all programmers are being replaced by code generators.
It's more complicated.
It's so much more complicated. The surrounding environment forces companies into a defensive survival mode before AI even fully enters the equation as an efficiency tool.
So what are the sources pointing to specifically? What's in that storm front?
The sources identify a few specific disruptive drivers. First, there's ongoing geopolitical conflict, and they specifically mention the Russian-Ukrainian conflict, which continues to just disrupt global supply chains, resource allocation, market stability.
All in unforeseen ways.
In unforeseen ways. The cost of key commodities, the reliability of manufacturing pipelines, these become major risks. And as you know, companies hate risk.
They hate it more than anything.
Precisely. Second, we're seeing increasing global trade friction, protectionist policies, tariff instability, rising tensions between major economic blocs, right, which makes it incredibly hard to plan long-term if you're a multinational tech company.
Exactly. It complicates long-term investment growth projections.
Yeah.
Especially for companies that rely on seamless global operations.
And all of that instability, I'm guessing, that translates directly into the third point, which is a sort of a slow, sluggish global economic recovery.
A very sluggish recovery.
Yeah.
After the boom years of the pandemic, if companies can't predict stable future growth, if consumers globally are tightening their belts, or if enterprise IT budgets are being slashed, market confidence just plummets.
The economic pie shrinks, and everyone starts fighting over smaller slices.
And this combination of geopolitical pressure, trade friction, and slow recovery. It has a catastrophic localized effect on financing. These macroeconomic conditions have created a pressure cooker effect. For many companies, especially newer firms that rely heavily on venture capital or those operating on thin margins, these conditions have led directly to what our sources call broken capital chains.
Broken capital trains, what does that look like on the ground?
It's stark. It means the expected next round of funding, whether it's a Series B or a major loan, it just dries up, or it's offered at impossible terms.
So your runway suddenly shrinks from 18 months to 6.
Exactly. And you have one choice: desperate personnel cuts, simply to stay solvent. These are what we call solvency cuts. They're distinct from efficiency cuts.
So you're cutting potentially high performers just to live long enough to reach stability?
You're cutting muscle just to live, not cutting fat to run faster. That's a really essential distinction for managing the anxiety of being laid off.
Yeah, understanding if it was a solvency issue, the company was drowning, or an efficiency issue, your job was automated. That tells you whether your next move needs to be a quick lifeline or a total strategic pivot. And this financial pressure, it brings us to the second major force, strategic restructuring, or what we've been calling lightening the load.
A perfect description, yeah. It focuses on the corporate agency in all this.
So the tech giants, feeling that financial pinch from the macroeconomic storm, they didn't just sit back and wait for the economy to turn around. They initiated massive corporate surgery.
That's a good way to put it.
We're seeing this widespread, aggressive mandate across the industry to reduce costs and increase efficiency. And this isn't just about reducing headcount, it's about fundamentally pruning the organizational chart and changing the company's entire operating metabolism.
And the method of pruning is critical here because it often sidesteps individual performance reviews entirely. Companies are aggressively cutting unprofitable business lines.
So any side project, any exploratory division,
Any established product that's too niche or isn't generating immediate, reliable profit, they're eliminating it, the whole thing. It's a ruthless triage process.
and that aggressive focus means that all the resources, the capital, the talent, the executive attention, they're being dramatically reconcentrated on what the sources call core businesses that determine life or death.
Exactly. If your company is known for search and cloud, for example, anything that doesn't directly support search, cloud, or the immediate path to AI integration is immediately on the chopping block, regardless of its potential long-term value.
And the devastating consequence of this is that the news isn't just about who got fired, but which entire department was eliminated.
Right. If the business line is cut, the entire team supporting it is gone. Developers, managers, marketing, everyone. The sources really emphasize that these structural layoffs are frequently unrelated to individual performance, which just compounds that sense of uncertainty and unfairness in the market.
Okay, so we've got the storm, we've got the captain throwing cargo overboard. Now let's bring in the lightning strike itself, AI substitution.
The accelerant.
How does AI accelerate the storm and become what the sources call the major pusher of job displacement?
So AI acts through two really distinct mechanisms of displacement, and both of them fundamentally change the demand for human hours. The first one is the most straightforward. AI models and automated processes replace basic repetitive positions. This is the automation we've been predicting for decades, now fully realized for specific predictable tasks in coding, QA, and basic operations.
Right, but I want to introduce a point of maybe necessary cynicism here. While the macro pressures are real, some critics argue the giants are using this storm as a convenient cover story.
To do what they wanted to do anyway.
Exactly, to execute AI-driven cuts they were already planning, allowing them to blame external factors rather than their own tech. Did the sources address that interplay?
They absolutely did. They frame it as opportunistic convergence. The consensus is that while the storm provided the excuse and the financial mandate to cut headcount,
The solvency and strategic cuts.
right, AI simultaneously provided the means to do so without sacrificing output. And those are the efficiency cuts. This is the second, more insidious displacement mechanism, especially for the mid-level programmer: efficiency multiplication.
This is the part that I think hits the higher-level programmer hardest. Because it's not being replaced by a machine, it's being outpaced by a peer who is better at leveraging the machine.
Precisely. AI tools significantly boost individual efficiency. If a single AI-enabled developer, armed with a powerful co-pilot and real prompt engineering skill, can now complete the work that previously required 2 or even 3 developers.
The result is the same. The company needs fewer people.
Exactly. They need fewer full-time employees to complete the same amount of work, or even more. Our sources call this the peers are rolling up effect. You're not being replaced by AI. You're being outpaced by the human next to you who has mastered their AI co-pilot.
That synthesis is so critical. Let's use the ship analogy the research provided to just tie this all together so you, the listener, can really visualize the full scope of this 2025 crisis.
Right. The analogy is of a ship caught in a massive ocean storm. The storm, that bad weather with the geopolitical conflict and the slow economy, that's the macroeconomic pressure.
That bad weather forces the captain to act defensively.
Right. He starts throwing non-essential cargo overboard to stabilize the vessel. That jettisoned cargo that represents the unprofitable business lines and eliminated departments, those are the strategic cuts.
Okay, so that's two forces. Where does AI fit in?
Simultaneously, the traditional human crew is being replaced by a more efficient, automated engine. That's the AI automation and co-piloting.
So the result is a much faster, much leaner ship that needs far fewer people to steer it.
But the initial decision to shed weight and reorganize was caused by the storm, not just the engine upgrade. You need both factors to really understand the scale and the urgency of what's happening right now.
Okay, let's move past the panic and into the pivot, because this is where it gets really interesting. The market chaos is actually creating genuine high-value opportunities for those who can pivot quickly.
Exactly. AI isn't just displacing people, it is fundamentally shuffling the knowledge system, forcing a technical and professional migration.
So we need to identify exactly which roles are in the decay zone so you know where to stop investing your time.
This is all about recognizing fixed patterns and predictable output. AI excels at high-repetition tasks where the patterns are predictable and the context is narrow. So this means the market value derived purely from implementation is plummeting towards zero.
So what specific jobs are on the chopping block? What does the research say?
The sources explicitly mention a few key roles. First and foremost, CRU engineers.
Create, read, update, delete.
Exactly. Those focused solely on those operations are highly vulnerable. Their work is just structurally repetitive because they're primarily interacting with standardized database schemas and endpoints. The whole CRU model is inherently predictable, which makes it perfect for generative automation.
Why is a database-driven role so perfect for AI replacement?
Because the models are incredibly good at pattern matching and standardization. They can look at your existing database schema, predict the required endpoint logic, generate all the boilerplate code, ensure input validation, and connect it to the ORM framework perfectly, every single time.
The human mason is just too slow and too error-prone compared to the machine.
Exactly. Then you have roles focused on routine testing and operations. They're shrinking rapidly.
So jobs involving basic maintenance, log analysis, that kind of thing.
Yeah, or repetitive Sunner testing,
Mm.
especially those with fixed patterns or known failure modes. They're being phased out. AI handles verification, regression testing, and basic infrastructure management perfectly, and often integrates monitoring and self-healing mechanisms directly into the deployment pipeline.
And the umbrella over all these dying roles is the one defined strictly by pure code implementation.
Precisely. If your primary value to the company is measured by the volume and quality of code you write for ordinary tasks, generating boilerplate, connecting APIs, writing standard functions, you are now competing directly with a machine that can do that much faster. 24/7. Pure code implementation, the heavy manual labor of software development, is shrinking dramatically. That is the decay zone.
But every contraction requires an equal expansion. We're seeing a mirror image of this decay in the growth zone, where entirely new demand is arising directly from this technology migration. The LinkedIn 2025 New Job Report highlights this really clearly.
Absolutely. While the traditional coding landscape contracts, the landscape defining, training, managing, and utilizing AI systems expands explosively. The highest demand new roles we are seeing are shifting the focus from application coding to model architecture and data strategy.
So which roles are leading that charge?
We see critical demand for AI engineers who build and fine-tune the bespoke models for enterprise-specific tasks. Data scientists who prepare and interpret the massive, complex datasets needed to train these models. Prompt engineers who specialize in communicating effectively and reliably with large models.
And importantly, AI ethics experts.
Yes, who govern the responsible and safe deployment of these powerful tools, particularly in regulated industries.
This sounds like a complete reprioritization of technical focus, a total knowledge shuffling.
It is. And we can group this new landscape into three major essential trends. The first trend is the decay we just discussed. Pure code implementation is shrinking.
Right.
The second is growth. New specialized roles in AI system architecture, prompt engineering, data strategy, they're emerging rapidly.
But the third trend is the one that offers the most immediate path to relevance for existing engineers, right? The fusion zone.
Is the ultimate survival area. The fusion zone is where traditional development roles, front-end, back-end systems, deeply integrate with AI techniques. They produce new intelligence areas.
So like a senior back-end developer who understands complex database optimization.
Is now using AI to write the optimization queries and then verifying the execution plan for scalability. It's about merging that old, deep expertise with the new, powerful tools, creating a hybrid, indispensable skill set, the AI-enabled domain expert.
This leads us to the fundamental change in the programmer's value proposition, the core value shift. Previously, the question was, can you write good code quickly and cleanly? Now that question has completely changed.
It has, because the AI handles that. The core value is no longer how to write code. AI has effectively commoditized that skill. The essential questions defining professional value are now what problem to solve and why to design it this way.
The programmer is being liberated from manual labor.
And simultaneously ruthlessly forced toward higher value creation, focusing on business outcomes and system integrity.
I found the shift from mason to architect analogy in the sources particularly compelling. Can we spend a minute making sure the listener understands the profound difference there?
Oh, absolutely. The analogy is perfect because it changes the source of leverage. In the pre-AI era, the programmer was the mason. Their primary value was determined by how quickly and perfectly they could lay bricks, write lines of code to build a stable feature. It was hard, precise, manual labor.
And often very repetitive.
Very repetitive. AI now performs the masonry. It lays the bricks faster, more consistently, and more accurately than almost any human.
So you can't be the mason anymore. You have to transition to the architect and foreman, managing the project, not building the pieces.
Precisely. The architect doesn't lay a single brick. Their value lies in designing the structure, deciding where the wall should go, ensuring the structural soundness, and most critically, verifying the fitness for purpose, that the building serves the business logic and the end user needs.
Can we apply that to a concrete technical example to really make it stick?
Sure. Let's take the simple task of creating an API endpoint that handles financial transactions, like an online purchase. The mason writes the 200 lines of Python code, ensuring it connects to the payment gateway and logs the result. The architect, however, spends 20 minutes deciding on the idempotent safety mechanism.
Explain what idempotency means in this context for someone who might not know.
It's the mechanism that ensures that if the user clicks the submit button twice, or if the network drops and the request is resent, the transaction only happens once.
Ah, okay. Crucial.
It's fundamental. And this mechanism involves highly specific business logic like a unique request ID that must be checked before processing. The architect designs that safety mechanism and specifies its implementation. It's often invisible in the resulting code, but it's fundamental to the system's reliability and the company's financial stability. The value is in the design and verification, not the implementation. This shift is just. It's non-negotiable for long-term relevance.
Okay, so given this profound shift in value from code writing to system design, survival is about strategically building a moat around your capabilities, specializing in the high-value areas where AI currently falls short.
That's the strategy, exactly. You are maximizing your human value where the machine cannot compete. If AI excels at patterns and repetition, we need to move toward complexity, ambiguity, long-term foresight, and human intent.
These are the areas where AI's training model fundamentally breaks down.
It does. It doesn't inherently understand future risks or unmapped dependencies because it's trained on existing data. So developers have to specialize in what we call non-functional requirements.
So the quality attributes of the system, not just the raw functionality.
Exactly. First, system architecture and design. This is the highest leverage point. Designing complex microservice architectures, choosing the right database topology for eventual consistency. These things require reasoning about costs, maintenance, and future unknowns that AI just can't do with sufficient reliability.
Then there's high-performance computing.
Yes. This involves specializing in low-level optimization, addressing parallelism, latency reduction, GPU optimization. An AI can suggest a C++ implementation, but ensuring that code fully utilizes cache lines or achieves maximum throughput on specialized hardware often requires deep manual expertise.
And what about the two most critical long-term concerns?
Scalability and expansion. AI can generate code that works for 10 users. Designing a system that seamlessly expands to 10 million users requires anticipating bottlenecks and architectural choke points that do not yet exist. That requires abstract future-proofing.
And finally,
The paramount mode. Reliability and security. AI can introduce subtle security flaws or hallucinate dependencies that create massive vulnerabilities. Detecting these, performing robust threat modeling, ensuring compliance with evolving regulations, that all requires human expertise.
but the most durable moat isn't purely technical, is it? The sources suggest it's the one that connects the technology back to the real world, the business logic moat.
That is the ultimate defense. A developer who understands both the technology and the unique business logic, the domain nuances, the regulatory environment of their specific industry, they are fundamentally impossible for AI to replicate.
So AI can write a perfect generic e-commerce backend.
But it doesn't understand the complex KYC know your customer regulatory nuances of global supply chain finance in Singapore, or the specific cultural demands of a niche healthcare market in Germany. That specialized, non-transferable knowledge is gold.
So as the sources suggest, the value hierarchy has completely reversed.
It has. Historically, the pure technical programmer sometimes looked down on the business developer or the domain expert, who might not be a brilliant coder. But now AI has leveled the technical playing field.
So deep business understanding is now higher value than pure technical skill.
The person who knows what the enterprise needs to survive and how to define success within complex constraints is more likely to remain than the person who only knows how to code the solution.
So armed with this architect business logic moat, engineers are advised to redefine their role entirely. You're not a programmer in the traditional sense anymore. You're positioning yourself closer to a product manager and architect, using AI to replace the jobs that used to exist beneath you.
This is the new programmer workflow. It turns the human plus AI dynamic into a single, hyper-efficient small team. The traditional roles of programmer and tester are essentially outsourced to the model, which becomes your high-speed, 24/7 technical subordinate.
Let's break down this new workflow, the 3 steps, focusing on the critical human intervention points.
Okay, so in step 1, the human architect PM assumes the highest leverage role. They handle requirement analysis, product design, system selection, technical selection. They define the what and the why, relying on that business mode we just discussed. They write the high-level plan and the comprehensive prompt.
Step 2 is purely mechanical.
Right. The AI subordinate handles code implementation and testing. The human offloads all the repetitive labor using tools like Copilot or Cursor to generate entire features, including tests, based on the requirements the architect provided.
Now, this is the most critical step and the one that often gets glossed over. Step 3. The human, architect PM, must verify and accept the final output. What exactly are we checking for here? What is the human's job in the verification stage?
The verification stage is where the architect earns their keep and prevents catastrophic failure. They are checking 3 primary things that AI models are notorious for messing up. First, hallucinated dependencies.
Meaning?
Did the model just invent a library or an API call that doesn't exist that could introduce instability or major security gaps? Second, non-functional compliance. Did the generated code meet the required latency goals, scalability targets, and security standards we defined in step 1?
And the third check goes back to that business moat.
Business logic integrity. The architect has to confirm that the code adheres to the complex rules defined by the business. Did it correctly implement that idempotent check? Did it handle the specific tax calculation rule for this jurisdiction? The human verifies the fitness for purpose.
The outcome is that the human plus AI functions as a small team that can handle an entire product line, which significantly increases their value to the enterprise.
Exactly. And this AI efficiency doesn't just enable specialized teams, it also lowers the barrier to entry across the entire tech stack, leading to the rise of the super full stack engineer.
This is a fascinating development. It changes the career trajectory completely.
It does. Previously, becoming a true T-shaped expert deep in one area, broad across the stack, was prohibitively expensive in terms of time and difficulty. Mastering every concept of every layer of the stack was a multi-year project.
Right, but hold on. If we only need to master entry-level concepts, aren't we just creating highly competent generalists who lack the deep expertise needed when the AI inevitably breaks? Where is the real defense against complexity if we're not mastering the foundational knowledge?
That's the essential risk, and the sources address it by redefining mastery. You still have to master the conceptual architecture and the principles of reliability, those are the moats we discussed, but you are liberated from mastering the syntax and the implementation details.
So mastery shifts from coding execution to conceptual design and debugging.
Exactly. You only need to master the entry-level concepts of a technology. the basic principles of deployment, structure, language, and then you can drive the AI to implement and perfect the actual code. This drastically accelerates skill acquisition.
And enables the rapid rise of the super full-stack engineer.
Right. They have a comprehensive architectural view of the entire problem, from front-end UX to back-end architecture and deployment logic. That makes them incredibly versatile and valuable in a lean, efficiency-focused enterprise.
If AI is the engine powering this new engineer, then the fuel that runs the system is communication. That makes prompt engineering not just a good skill, but the new mother tongue, the essential language of this new economy.
It is mandatory for survival. Prompt engineering isn't just about asking nicely for code. It's about designing complex, multi-step inputs to ensure controlled and precise output from large models.
It's about defining the context, specifying non-functional requirements.
Right, saying things like, the code must run in OEN complexity and adhere to OWASP security guidelines, and setting the output format. Mastering this is what allows the human to truly function as the architect.
And to achieve that human-machine unity we talked about, specific tools are essential. We need to know which AI code editors are the must-haves and are worth paying for, because efficiency gains here translate directly to job security.
Based on the source material, there are 3 tools named as nail-hard goods that made it through the real-world testing process. They should be integrated into every professional workflow: GitHub Copilot, Cursor, and Cloud Code. The goal is mastery, being able to seamlessly integrate the tool so that you are thinking about the architecture and the tool is instantaneously generating and proposing the implementation.
And we also have some very practical tips on how to use these tools effectively, especially Copilot, which is the market leader.
Yes, there's a recommended duality in usage. For discussion and context building, when you're defining the what and why, you should use the ask mode, the chat interface. This lets the AI ingest the surrounding code and context.
And then for generation.
For the actual code generation, when you know exactly what you need, you switch to the assist mode for rapid code completion.
And let's share the specific high-leverage model selection tips the sources provided. We shouldn't treat all models as interchangeable.
Absolutely not. The sources point out that different models excel in different domains. When you are purely writing code and generating clean, idiomatic boilerplate, Cloud Anthropic's family often yields the best results.
Why is that?
It has a focus on long context windows and security. For complex logical reasoning, especially architectural breakdown, Gemini 3 is highly suitable. Its multimodal context window allows it to hold complex architectural diagrams or external documents in mind simultaneously.
And for when things inevitably go wrong.
When you run into issues, GPT-5 is cited as the best tool for solving errors and debugging. It acts as your expert diagnostician. I recently spent an hour debugging a subtle security flaw that I just couldn't spot, but GPT-5 immediately identified the missing input sanitization logic.
So you treat them like a specialized toolbox. You don't use a hammer to tighten a screw.
Exactly. And one final crucial practical tip for the programmer: working with AI is something that saves a ton of headaches.
What's that?
Since AI often modifies existing code as it generates new segments, sometimes making sweeping changes across files, you must constantly use Git and version control to save code promptly. Timely saving and granular version control are no longer just best practices, they are necessary safeguards.
Okay, so while traditional employment is contracting, the beauty of the AI revolution is that it simultaneously enables entirely new working models with unprecedented leverage. For those facing job loss or who just want a more autonomous path, the opportunity for entrepreneurship has never been lower cost or faster.
Right. We're seeing the powerful rise of the one-person enterprise.
How is that possible?
This model is enabled by the fact that AI drastically reduces development costs. You've outsourced your Mason and your tester, and crucially reduces verification and iteration cycles. This means a small team or even a single individual can realistically complete complex projects that once required a dozen people and substantial capital.
And the communication cost in one-person setup is near zero.
Which eliminates the major bottleneck of traditional startups.
So what are the immediate startup opportunities fueled by this leverage for a technical person?
3 areas are highlighted as particularly ripe. First, vertical applications based on large models. These are hyper-niche tools that solve a very specific high-pain problem, like compliance automation for a specific medical billing procedure. Second, AI-native SaaS tools, which are built from the ground up to utilize AI efficiencies. And third, solutions for enterprise process automation. helping existing mid-sized and large companies streamline their internal workflows, which are often still surprisingly manual.
Regardless of the cutting-edge technology, the fundamental rule of success remains, doesn't it?
It never changes. The core of entrepreneurship is still to find and solve a human pain point. The stronger, sharper, and more specific the pain point you address, the higher the chance of success.
As programmers, our natural tendency is to pursue technical perfection.
But the sources stress the need for radical execution over perfection. You must use AI to build a minimum viable product, an MVP rapidly for market validation. Get the functional core of the product in front of users quickly. This drastically lowers the cost of failure.
So if the MVP doesn't resonate, you pivot immediately.
Exactly. The sources even suggest you don't necessarily have to start with a complex application. Starting with a service or high-value content can integrate resources at the lowest cost, validating the need before you invest heavily.
This leads perfectly into the second alternative path, leveraging personal IP intellectual property, which taps into the concept of zero-cost replication leverage.
Right. This concept, popularized by thinkers like Naval Ravikant, identifies modern leverage points: labor, capital, and products with zero marginal replication cost. Things like code, media, books, information products. This last category is where the average person has the greatest opportunity.
Because it doesn't require permission or massive capital investment.
You just need time and insight. And for a technologist with unique domain knowledge, creating personal IP is relatively simple.
How does that strategy work in practice?
It involves creating high-quality technical blogs, in-depth video tutorials, or sharing detailed AI programming experiences, especially what the sources call pit-filling records, documenting and solving common, tricky problems that you mastered using AI.
And this IP can then be monetized.
Through knowledge payment, subscription models, community operation. While the early gold rush of social media influence is over, building a technical audience is still a superb, output-based hobby that inevitably yields rewards and provides a powerful secondary income mode.
We are also seeing a major global shift toward remote work and the digital nomad lifestyle, a trend for which programmers are uniquely suited.
This is a powerful macro trend that's gaining corporate validation. Our sources cite Trip.com's significant policy change, implementing a home office without approval policy for employees starting this September.
And a shift like that from a major multinational signals that large companies are recognizing the efficacy of remote productivity.
Especially when it's augmented by AI tools that standardize workflow and measure output objectively. Programmers, whose work is inherently digital, are the perfect candidates for the digital nomad lifestyle.
For someone who just lost their job and wants to transition to remote work in a new location, where should these new nomads look to set up shop?
The sources mention several specific, affordable community locations, popular digital nomad hubs like Bali, Chiang Mai in Thailand, and Portugal. They offer a dramatically lower cost of living than major U.S. or European tech hubs, allowing you to stretch your capital further while joining existing communities.
And the preparation needed to take advantage of this nomadic freedom differs slightly from traditional job seeking. It's not just about a resume.
Right. A remote employer needs proof that you are capable of operating autonomously. This means preparing a comprehensive portfolio, showcasing applications you've built, maintaining a robust personal website, active and well-documented GitHub projects, and a well-curated LinkedIn account that focuses on results and leverage rather than just titles.
So you're demonstrating your unique value in an AI-enabled remote context, proving you're the architect, not the mason.
That's the key.
As we wrap up this strategic look, we have to acknowledge the elephant in the room, the emotional toll of uncertainty. This journey is often stressful, terrifying, and the path forward is ambiguous. Our sources wisely shared some philosophical ideas to help manage that crippling anxiety.
Yes, navigating a massive structural shift requires mental resilience above almost anything else. The sources bring in the ancient Chinese game of Go with the term Wei Xiang. It describes a group of stones that is half alive, half dead, surrounded by the opponent. But its fate is undecided, requiring ongoing effort to establish life.
It's a perfect metaphor for the modern career. You're not immediately dead, your skills aren't instantly worthless, but the future is unclear and every choice feels high stakes. It's the feeling of being in limbo, where commitment feels risky, but abandonment guarantees failure.
Exactly. And the cultural observer, Guo Degang, is referenced with his term miwu, or mist. When facing major life decisions, people often feel they are in a dense fog, unable to see their position, their destination, or the danger ahead. In the AI era, this feeling of new woo is rampant and paralyzing.
So, what's the anchor? How do we convert that vague, debilitating anxiety into controllable, productive action?
The solution lies in the philosophy of Thich Nhat Hanh, specifically mentioned in the sources, and the concept of the miracle of mindfulness. The advice is practical. Don't let your mind race to hypothetical futures. You have to focus entirely on the present moment and what is controllable.
Convert that vague anxiety into focus on small, daily progress.
Mastering one prompt engineering technique, refining one section of your portfolio, or deeply understanding one aspect of your business domain. By focusing on each day's steps, the path forward will gradually reveal itself, pushing the mist away piece by piece.
And finally, a necessary high-level reassurance rooted in physics.
The ultimate reassurance is the acceptance that uncertainty is the normal, fundamental state of the world. The world's true nature is described as being quantum, inherently uncertain, and only defined by the probability wave until action is taken. Learning to accept and even enjoy the ambiguity of the Miwu and Wishang states is the final step toward mental freedom in this era. The path forward will reveal itself not through perfect, agonizing planning, but through decisive, continuous action and belief in your ability to adapt.
This has been an intensive, detailed look at the 2025 tech landscape. The crisis is not just one thing. It is multi-layered, driven by macroeconomics, strategic restructuring, and the powerful commoditizing push of AI. Survival hinges on shifting your core professional identity from coder, the mason, to architect, the foreman. This requires building a durable moat of business logic and non-functional expertise, and viewing AI not as a replacement, but as an essential high-performing team member that increases your personal leverage exponentially.
We are undeniably in the best and worst of times simultaneously. AI is ruthlessly killing professions that rely on repetitive logic and implementation, but it's creating so many new ones that rely on uniquely human ingenuity, design, critical thinking, and domain knowledge. The sources are clear. The most important defense against job displacement is maintaining a fierce, lifelong learning attitude and continuously updating your knowledge base, particularly in system architecture, business domain, and prompt engineering. The tools are ready and waiting. The commitment to self-reinvention has to follow.
So what does this all mean for you, the listener? The ultimate high-value output in the AI era is finding a human pain point and designing the solution. If AI handles the how, the implementation, the code generation, the testing, then your value is entirely centered on the what and why. Hmm. Our final provocative thought for you to explore today, right now, is this. If implementation is solved, what are the three most pressing human needs or structural pain points in your current industry that no one is currently solving? And how would you, the architect, start prototyping those answers using your new AI team member today? Start prototyping those answers.